Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We'll continue our lecture about the PIC16F877 microcontrollers. Now we will discuss about the timers itself. That you know that the PIC16F877 have three timers: timer 0, timer 1, and timer 2. So let's begin about the timer 0 first. Just as you know, the basic concept of the timer itself, right here, is the facility that is used to measure time or generate an accurate time. So, measure time from one event to another event, or generate an more accurate delay time. Because you can make your delay time using the while loop, fixed while loop, or the for loop. But I don't suggest you to use that kind of method because it's not very accurate. If you want to generate an accurate delay time, you can use the timer. So the microcontroller can also generate or measure the required time delay by running the loop. Okay, and the timer counter can reduce the CPU load of the repetitive task, allowing it allocate the maximum processing time to other tasks. So that timer module in the microcontrollers for general is a separate module from the ALU or CPU inside the microcontroller itself. So it can run parallel. Okay, so what is the timer itself? The timer is just a simple binary counter, as I read here, which can be configured to count pulses internally or externally. After reaching the maximum value, it will return to 0 by setting the overflow flag. Okay, you know the overflow flag, and generating interrupt if you enable it or you make it that overflow flag can generate an interrupt. So the overflow flag itself is just a flag that indicate that the timer is reaching the maximum value. So from the maximum value then to the beginning of the value, the 0 value. So the flag overflow will setting up. Okay, so that's the concepts of the timer itself. So this is the illustration about the basic concept of timer. You can watch it in the exploreembedded.com. But right here you can pick or select the source of the timer, whether it's oscillator right here or maybe external clock source, yeah. And then the from either the oscillator or from the external clock is to enter the prescaler, divide by 4, divide by 6, divide by 8, and etc. So the output from the prescaler is input or is through the AND gate, something like AND gate to enable the timer. So if you enable the timer, then the clock itself can go to the timer counter. Okay, right here. So the timer counter is going up 1, 2, 3, 4, 5, and so on, and then to the overflow flag, which is indicate that the timer is have a maximum value and is going to the 0 value, from the maximum value to the 0 value. And this event, this overflow event, can generate other tasks or other programs if you enable the interrupts. So that's the simple concept or basic concept of the timer itself. So what about the timer module on PIC16F? So the PIC16F877 has 3 independent timers timer 0, timer 1, and timer 2, which can be used as a timer counter or for PWM generator. Only timer 2 used in the PWM generator. If you generate the PWM signal, you can use the timer 2. That's for the PIC16F. You can read each of the microcontroller datasheet to learn about to learn more to learn learn more about the PWM and the timer itself. So this is the timer module and the registers, which is according to the each of the timer. There are three timers, as I mentioned before. The timer 0, the first timer, the second timer, and the third timer. The first and the third timer is only 8-bit, but the second timer, timer 1 here, is 16-bit. So the timer 0 is 8-bit, has a control register is in option rack. It's different from the third timer or timer 2, also in 8-bit, but the control register in the T2 COM. And the timer 1 is in the T1 COM. And this is the control register. The other is the count register itself. It holds the timer count value, which will be incremented depending on prescale configuration. So this is 8-bit because the second timer is 16-bit. They need two kind of count register. For the timer 1, there are timer TMR1H and TMR1L, high and low. But for the first timer and the third timer, timer 0 and timer 2, only TMR0, and for the timer 2 is TMR2. So that's the two kind of register, the control register and the count register according to the timer itself. So the minimum delay for each of timer, it's also the same. It's about 0.2 microseconds to tenths or 0.2 microseconds, but the maximum delay, because this timer is 16-bit, is more the longest maximum delay compared to according to the first timer and the third timers. Okay, that's the timer module. The summary first, the summary of the timer module on PIC16F877. So we talk about the timer 0 in this lecture. Timer 0 is a module as 8-bit, okay, not 16-bit, 8-bit timer counter with the following features. This following features is also the same for the timer 2 on the third time, also the same. But if you want to use the timer 1, so this is not 8-bit but 16-bit, okay? So 16-bit. So this TMR0 has the following features. The first one is the 8-bit timer. Is you can use as a 8-bit timer or 8-bit counter. And also the value of the timer is readable and also writable. And the prescaler can be programmable, can be programmed by software. And you can select the internal using oscillator or external using another source of clock itself. The interrupt of overflow is the event is if the value of the timer itself is FF to 00, and also at select for external clock. That's the brief of the features. Yeah, you can learn more about this timer in the PIC16F877 datasheets in the timer section. So let's see that beside option rack, in the timer 0, beside option rack, there are also anti-ML0, there are also ENT COM. This register is only contain the timer 0 overflow, like STMR0EF, and also corresponding interrupt enable TMR0EA. So F is stand for the flag, E is stand for the enable. So there are three kind of register, but the important one is the two. Okay, option rank and timer. If you don't want to use the interrupt, you can you don't have to use this register ENT con if you don't want to use the interrupt. If you want to use interrupt, so ENT con is should you use to uh, to read the overflow status and also to configure the enable. So this is the option rank. Just as you can see, is 8-bit register as from 1, 2, 3, 4, 5, 6, 7, and 8 bit. So, sorry, the last of 2 bits is according to the port P or interrupt, external interrupt of RP0. But we want to know about this right here. It's according to the timer 0 itself. So the first one, PS0, PS0, PS1, PS2, this according is prescaler rate. So if you don't want to divide the watchdog timer, you can use 000 configuration. If you want to half of the rate, is you can use also the 00, the MS0 rate from divided by 2, divided by 4, 8, 16, and etc. And then PSA is prescaler assignment. Okay, prescaler assignment bit. Prescaler is assigned to the watchdog timer. So the prescaler you can choose. You can, if you want to use a watchdog, you can use the TMS0. If you use the TMS0, you can use the watchdog timer. So this one is to select which prescaler you use. If you want to use the prescaler for the timer 0, so the PSA should be reset. Okay, should be reset. The value is 0, so the prescaler is assigned to the timer 0 module. So the other ones, the next bit is T0SA and T0GS. T0SA is a timer 0 source at select bit. So if you save the 0 value, it means that you increment and low to high. Okay, the clock is from low to high. If you want to high to low, you should set this bit. Okay, you should set this bit to the 1, so you can use it. So I want to give an example here, right here. So this one, this one is low to high. Okay, here, right here, low to high. But this one is high to low. So the trigger is right here. The trigger for the X, TMS0 source X. You can use from high to low or from low to high. If you want to high from low, so you have to make T0SA to 1. If you want to make low to high, it's 0. Okay, that's it. So the other one, the last one is T0CS. So T0CS here is to select with clock source. If you want to internal instruction cycle clock, so you can reset the T0CS. If you want the transition in the RA4 T0 clock input or CMP2 pin, CMP2 pin, you can set this bit. So this is the option rank according to the TMR0. So this is the register associated to the timer 0. As you can see, this timer 0 modules register to set to hold the value itself, and then the option rank, and also the ENT con. So it's only here to enable the interrupt. You have to set 1 here, and just take a look here to, if you want to know, is there any flag according to the overflow or not yet. So this is only the two bits here according to the timer 0 itself. Okay, so that's the option, right? And then the register associated with timer 0. There are three registers: the M0, ENT, con, and option. So this is the timer block diagram, excluding watchdog timer. So if you want to use the oscillator, you can use this one. So you can you can use this one, or you can use the RA4 from the external or the internal. F oscillator is always divided by 4, and then you can select the T0CS here, like the T0CS. You can make a 1 here, 1, and then the PSA is according, if you want to use the prescaler, to the timer 0 itself, and then the sims to cycle and also the TMR 0 regulators is for the value itself. Okay, so this is the example of the calculation at the timer, especially for the general rules, that the PIC oscillator frequency is always divided by 4, okay, which is then fed to the controller. Now this frequency can be further divided by the prescale to produce a delay range. So this is the equation according to the timer tick. That the tick is equal prescaler divided by F oscillator divided by 4. Or the prescaler, maybe you can use the oscillator as 20 megahertz, so you can say here 20 megahertz. If you for the general, the prescaler is multiplied by 4, then divide by the oscillator, the frequency of the oscillator itself. It's very simple equation to calculate the timer, especially for the timer tick. Okay, the timer tick is just like the clock itself. So the timer value for the required delay can be calculated as below, because you can you already calculate the tick timer. Then the delay is equal to timer count multiplied by tick. Count is delay divided by tick. So and so on and so on and so on. So we have right here the equation right here. Break value is equal to timer max minus delay multiplied by oscillator divided by prescaler multiplied by 4. So the summary of all of the timer right here, the timer 0 is 8 bit, the timer 1 is 16 bit. So the equation for the timer 0 and timer 2 is equal, but difference from the timer 1. The timer 1, the timer max is 65,536, but if the timer 0 is only 200, the timer max is only 256. Also the timer 2 is also 256 minus delay multiplied by F oscillator divided by prescale multiplied by 4. You don't have to manually calculate, because there are some software can be used to calculate the timer at the PIC microcontroller timer. So for example, delay calculation, if you want to delay the 1 millisecond using the 20 megahertz with the prescale 32, so in the timer 0, so you have to write this 256 minus delay. The delay is 1 millisecond. The frequency of the oscillator is 20 megahertz, and divided by the prescaler multiplied by 4. 32 multiplied by 4. So the answer is 100. So the register value you should hold in the timer itself is 100 decimal. So the next one is how to program the Timer0 itself with 7 steps. The first step is you have to calculate the timer count for the required delay using this kind of equation. Okay, and then you can set the prescaler and option right, and then you can clear the PSA bit because you have to use the prescaler, and you can then select the clock source internal or external using P0CS. Load the timer value into the TMR0 register, enable the interrupt, and also enable the global and peripheral interrupt by setting GIA and BIA bits. So this is our first example. This one is interrupt timer. So I need to move to the next slide. Okay, before we discuss about the interrupt. So the trigger is 0 for PQ40 as output to blink LED, for example, to blink LED in the 40. Option right is 1 to S bit S2. S bit S2 is number 2. Timer 0 with external frequency 32 as prescaler. Okay, so 2 bit. Okay, the TMR0 is 100. Just our calculation. TMR0 interrupt enable is 1. GI is 1, BAI is 1. That's it. So this is the forever loop for the 40. The 40 is always send the value, and the value can change in the interrupt subroutine, timer interrupt subroutine, especially the timer 0 subroutine. So if the timer 0, so this is the general interrupt subroutine for the timer. So you should have you must or you should check if the overflow in the timer 0. So this is true. If TML0 EF is equal to 1, there is overflow in the timer 0. So value is negation or inversely from the previous value, complement of the previous value. And then the timer 0 is root the timer. Note, timer 0 is 101 instead of 100, as the timer 0 needs to instruction cycle to start increment timer 0. So you need to not 100 but 101. So clear the timer interrupt manually using this kind of instruction, and then the program is going loop forever. So the blink of the LEDs is according to the interrupt. Okay, in the first example you can blink the LED using the delay, but for this example the blink of the LED using the interrupt for 1 millisecond. Okay, because 100 is for the 1 millisecond. It's very fast to our eye. Okay, that's a simple example. So you can check with the oscilloscope for the output of the timer. This is 1 millisecond delay. So there is a software for the timer 0 calculators. So this is PIC16F. Okay, PIC16. The MCU clock is 8 megahertz. Choose the timer, and we want to 1 millisecond. Okay, so this is the result. If you want to calculate you have to click the calculate, and then the program generate the script or the listing of the programs. You can copy and paste to your program. So this is the result from the program. Void anything timer option rank is 82. TMR0 is 6, and count is A0. Void interrupt. Void interrupt if TMR0 is this is clear for the interrupt, and TMR is 6. Okay. So you can enter your code and here the subroutine itself. So what about if I want to change from 1 millisecond to 10 milliseconds? Using the frequency is also the same, 8 millisecond. So this is 10 millisecond. There is a difference in actual interrupt timer is about 9.984 millisecond, and user enter the interrupt time 10 millisecond. The difference is 16 microsecond. So this is 8 calculation error, because not exactly the 10 milliseconds. But if you insist, you can copy and paste the program itself to your program, but be careful, because the delay is not 10 okay, 10 milliseconds, but 9.9884 milliseconds. So the option rank is 86, kernel is 100, indicator is 0, and etc. So this is the how to easier calculate the constant or the value according to delay you want. But be careful, because if the clock frequency and the interrupt timer, if you want to interrupt, is not matched. There is error. There is error and not accurately anymore. For example, if you want to have a 10 millisecond using the 8 megahertz of the clock frequency, so there are error in the program. So in this case, you can have 10 millisecond, but it's almost 10 millisecond, 9.9. Okay, if you accept this kind of accuracy, so go on. I think it doesn't matter anymore. But if you want to more accurate, if you want to explicitly 10 milliseconds, so you have to change of this kind. Or you want to change the interrupt time, or you can change the clock frequency of the CPU microcontroller itself. So you can have a max pair of the MCU clock frequency and the interrupt time, just like here. If you want to make a 1 millisecond using 8 megahertz clock frequency, that's the good pair. The good pair according to the clock frequency and the interrupt time. But that's important rule, important notes. You can use this kind of the calculator, so you don't have to calculate manually. You can enter this kind. You can save this configuration using this button here, so you can recall with maybe another millisecond, and just to be careful, because I think this software is good enough to generate or to calculate the value of the timer exact. Sorry, this one is using timer 0. So this is the timer 0. You can choose the timer 0, timer 1, or timer 2. Maybe if you want to this 10 millisecond delay, you can use other timer, maybe timer 1, which is 16 bits. But I think if you change timer 0 to timer 2, is always the same. But I don't try yet for the timer 1 or the second timer. You can try it for yourself. Okay. So that's our lecture about the timer, especially for the timer 0. So next we will discuss about the timer 1 and timer 2 and some of the example according to timer 1 and timer 2. Just like I mentioned before, that the PWM generator use timer 2. So if you want to generate the PWM signal, you can use the timer 2, because the timer 2 is already used for the PWM signal generator. Okay, thank you very much. See you for the next one.